Hey guys, and welcome to this video on the Vigenere Cipher. I hope I'm pronouncing it correctly. I believe it's French. So first we're going to go ahead and I'm going to create a title for our program. I'm just going to call it Vigenere Cipher. And please don't get worried if you see me spell cipher with a Y instead of an I. Apparently you can use both. All right, so we're going to go ahead and create a description for our program. So this program takes in a plain text and produces a cipher of that text using the Vigenere cipher. All right, so let me show you what I want the program to do. So the usage, first I want us to print out, please enter a sentence or word you want to encrypt. And then the user will input some word like defend, and then we'll output the ciphered text with key um, key shift equaling hello is, and then we'll have the encrypted text of that using the Visionnaire cipher KIQ PBK. So now I'm going to show you how it works, the Visionnaire cipher. So they have a nice little formula. Vigenere Cipher encryption formula. So here it is, C at position I, and I is just the index, is equal to P at position I plus K at position I modded by N. Okay, so what are all these letters and things, right? Well, our C is equal to our cipher. Our K value is equal to our secret key, which is just a word. Our P is equal to the sentence or plain text or word that we want to encrypt. And N is equal to the number of letters in the alphabet. Okay, and now really more specifically, if our key, if the word that we're using for our key is or has a length that's less than the plain text that we're using, then it's very possible that this index could go past what the key's length is. So we have to make sure that we keep it within the key's length and go back to the beginning of the word that's in the key. So in order to do that, we're going to mod it by the length of k, and I'm going to call it k length. And hopefully I'll explain that a little bit better, giving you an example of exactly how we have decrypted this word defend using the Vigenere cipher. Okay, but first we have to suppose that a letter is mapped to a value. So that means that A equals 0, B equals 1, C equals 2, D equals 3, E equals 4, F equals 5, G equals 6, H equals 7, I equals 8, J equals 9, K equals 10, L would equal 11, M would equal 12, N equals 13, O equals 14, P equals 15, Q equals 16 all the way to z, which would equal 25. Okay, and suppose that we had a key of hello from our example. So key is hello. Then what we want is we want the ciphered letter. And we can do that by making our plain text letter an integer, adding it to our K letter. I'll call it K letter, or yeah, sure, we'll say key letter. That's even better. Our key letter, and it needs to be an integer. And then we mod that by 26, which is the number of letters in the alphabet. And then what it does is it returns a ciphered letter as a number that we call a cipher value. Okay, and then we're going to take that value and we're going to cast it to a character. So we're going to get the equivalent character for that value. So cipher value, and of course again this will just equal some encrypted letter. Okay, so now let's see how this encryption actually works. So first we have our character here in defend. This is our plain text. Our key is hello, and this is our encrypted text. So we first look at the letter D using this formula here, this Vigenere encryption formula. We look at the letter D, and right now our ith value is equal to 0. And then we look at our letter K. So we add D to not K to H. So we add D to H, which is our first letter for our key. And we have to remember we have to find the values for D. So D is equal to 3, and we have to find our values for H, and H is equal to 7. So we get 3 plus 7, which is 10, and then we mod it by n. N is 26. So we get 10 modded by 26, which equals 10. So then our cipher value is equal to 10, and the corresponding character is the letter K. So then we put K here for our encryption of the letter D. Then we go to the next letter, which is E for our plain text, and it happens to be E for our key. So we look at the value of E, which is equal to 4. So we do 4 plus 4 modded by 26, which is 8. And then we see that the corresponding letter to 8 is I, so we put I. Then we go to our next letter, which is F. And our next letter in our key is L. So we do F, which equals 5, plus L, which equals 11, gives us 16. Then we do 16 mod 26, which is still 16, so we get Q. And we put Q here. Next up, we go to our next letter in our plain text, which is E, and the next letter in our key, which is the second L. So E is equal to 4, L is equal to 11, so we get 15, and 15 mod 26 is equal to 15. So our 15 maps to P, so we put P here. And then we are going to go to our N and our O here. So we look and we see N is equal to 13, and we see that our O is equal to 14. So 13 plus 14 is 27. 27 mod 26 is equal to 1. So then we look at the character that's associated with the value 1, which is B. So we place B here. Then we get to our letter D, and we notice that we run out of letters for our key here. So we have to go back to the beginning here, which is why we mod this index here by the length of K. So right now if I was an index that started from 0, it would be, let's see, 0, 1, 2, 3, 4, 5. So it will have a value equal to 5. And the length of k would be 1, 2, 3, 4, 5. So we have 5 mod 5, which is equal to 0. So that means that we go back to the 0th index of k. All right, so again, we have the letter D. We look at the number that it's associated to, and D is equal to 3. And then we go back to our H, and we see what number that letter is associated with. And H is equal to 7. So we get 3 plus 7, that gives us 10. 10 mod 26 is 10. So we put the letter K there. All right. Now, a little side note. So note that the ASCII values of lowercase a is equal to 97 and not 0. And lowercase b is equal to 98 and not 1. And lowercase c is equal to 99 and not 3. Or is it? Yes, it's 99. Okay. So I said not 3. I meant to say not 2. There we go. That makes more sense. Because you just have to add 97. So this is for lowercase letters. And the ASCII for uppercase letter A is equal to 65. And for uppercase B is equal to 66. And for uppercase C is equal to 67. And this is for uppercase letters. All right, so let's go ahead and get started on our program. So first what we're going to do is initialize our libraries. So I'm going to include stdio.h. So this will give us the fgets function, which allows us to take in a sentence or a word. It gives us our printf function, and it gives us our stdin file pointer. And then I want to include string.h, and this will give us the string length function. And then I'm going to include our ctype.h, and this will give us the functions isUpper, which returns, I believe, 0 if it's not an uppercase letter. So it checks to see if a letter is uppercase or not. Is lower, which would return, or which would check to see if a character is lowercase or not. ToLower, which would make a character lowercase, and then ToUpper, which would make a character uppercase. All right, and I'm going to go ahead and declare my function. And I'll call it Vigenere Cipher. So let's declare our Vigenere Cipher function. It's going to print out every character, every ciphered character. So it's not going to return anything. It's going to be void. And again, I'm going to call it Vigenere Cipher. And it's going to take in a plain text, a sentence or a word. And then it's going to take in a key, which would be a word. That's going to be our key being used to encrypt our plain text. And then we're going to create our main function. I'm going to return 0. And we'll need our key. So I'm just going to set it equal to hello, since that's what we're using in the example. So right here we are assigning the key. And then I want to create my plain text. It'd be a size 101. So right here we're just declaring a string for a user's text to encrypt. All right, and now let's ask the user for a sentence or word to encrypt. So that's printf, and then the stuff we want to ask them. So I'm just going to copy and paste this here. So copy that, and then I'm going to paste it there. Perfect. And then what we want to do is we want to get the encrypted, I'm sorry, we don't want to get the encrypted text. We want to get the user's input, which is the plain text. And we can do that by using the fgets function, which takes in the plain text. It's going to take in the size of plain text. All right, and then we need our file pointer, stdin. So standard input. And let's see, next we want to print the encrypted plain text. So we do our print statement again, and I'm just going to copy this up here and then paste it. So the ciphertext with key shift hello is, and then we're going to of course print our we're going to print the actual encryption. Okay, now of course suppose that our key shift is not always hello, so I'm just going to put %s here instead, and then I put k, so that if we decide to change the keys text, then it'll show when we print it out. So I'm gonna go ahead and run this. Well, first I'll save it. Save it as .c, and I call it Vigenere Cipher. Okay, let's run it. All right, I have some problems here. K is undeclared. Oh, because I called it key and not K. So let me call it K, and K is our key. All right, perfect. So let me enter a word like defend, and we see the ciphertext with key shift equals hello is blank. All right, and maybe here instead of me calling it key, I just call it K as well. All right, so now let's go ahead and create our Vigenere cipher. So I'm going to copy and then paste this formula here so I can look at it while I'm programming. Now what we're going to need is we're going to need a few variables. We're going to need an index I to keep incrementing. We're going to need our cipher as a character. So that's our ciphered character, or that would be our C value here in the formula. We have our plain text P, which is here. We have our K, or our key, which is here. So I may also need, I may also need a cipher value. All right, that's going to be our cipher value. And then we need to know the length of our K value, and we can use string length for that. So we know the length of K. And that's so that we can make sure that we start back at the beginning if we go over the length of K. All right. Now let's loop through the length of the plain text, and that's what we'll put here. Loop through the length of the plain text string. So it's going to create a for loop. It's going to run for I equals 0. I will be less than the then the string length of our plain text, and then I is going to increment by 1 each time. Okay, so this right here will allow us to loop through every single character in our plain text. So now, if the character is lowercase, so that means that the range is 97 to, let me make sure I'm adding this up right, 122, I believe. So we need to check that. So let's see, if is lower, and then we take in our plain text at position I. So if this is true, then our cipher value is going to equal our plain text yep, at position I. I'm just following this formula up here now. Then plus the integer value of our key at position I, modded by the key's length, and then we're going to do all that modded by 26, which is the length of our, I'm sorry, not the length, well, maybe. It is the number of letters in our alphabet. So this isn't actually done because our range is 97 to 122. And so because of that, I have to subtract 97 here to make, you know, that value work correctly. Subtract 97 here, and then I need to add 97 here. So this makes sure that all the values we get are in range 97 to 122. All right, and then our cipher is going to equal the character of cipher value. All right. Now, else if it's not lowercase, is uppercase. Well, it could be uppercase, or it could be a space, or it could be a dash, something like that. That's okay. We'll handle that later. So where letter range is 65 to 90. So this is uppercase. And what I'm going to do is I'm basically going to take this here, and I'm going to copy it and paste it here. So now, of course, this is 65 instead of 97. So I just subtract 65 here. I subtract 65 here. And then I add 65 here. Okay, so perfect. Now, what I need to do is I need to make sure that that K value that we're using, I want to make sure that it's the same, you know, both ways. So if we're using a lowercase key, and we're using an uppercase plain text, I want to make sure that the key is also uppercase. So, and I want to make sure that it's vice versa as well. So in order to do that, I am going to use the toLower function. And we're just going to put in all that right there into our function to make sure it's lowercase. And for uppercase, to upper, and we're going to put in all of that right there. Okay. So now let's check to see if we get a space or not. So we're going to print the ciphered character if it is alphanumeric. So basically if it's a letter. So if is alpha, then, oh, we need to take in plain text. I'm not sure if I put what is alpha is, but this basically tells us if the character is a letter or not. And it comes from our C type. And I did not put that up here. So I'll put that there, is alpha. Okay. And so if it is a letter, then we're going to print the ciphered letter. So %C, and we're going to print this cipher. Else, it's not. So else, oops. Else, if the character is not a letter, then print the character. And an example of this would be printing a space. And so we just printf the letter of the plain text at position I. Okay, and now let's just call our function, our Vigenere function, cipher, and take in a plain text from the user's input, and then take in a key, which is K, and let's see what we get. Okay, I'm going to use our example, defend, and we get exactly what we wanted. Let's take a look there. Yep, so KIQ-PBK, and now I want to check for uppercase. So I'm going to put in defend again, but all uppercase, and perfect. So now we get uppercase KIQ-PBK. So thank you guys. I hope you really enjoyed this video on the Vigenere Cipher. Please leave likes, comments, please subscribe, leave questions, and if you think this video was very helpful, make sure to share it with your friends, family members, teachers. So anyways guys, thank you for watching, and I'll see you guys in the next video.